Hi everyone. Today is our final lesson in Chapter 1, where we're going to evaluate evidence about gases in the atmosphere. This lesson is a little bit longer, not necessarily that my video is going to be a little bit longer, but the amount of work that you have to do is going to be slightly more than average. So for this purpose, I'm giving you 2 days to complete this. However, I know that the date is going to say that it's only due in 1 day. I just wanted to make sure that you guys were looking at this. So just know that you will have a little bit more time to complete this lesson. We are on Unit 7, our last unit, Chapter 1, Lesson 5. You should open up Amplify before you even start the video. There's going to be a few new tools that we haven't really worked with in a while. So please follow along, and again, rewind if you see something or hear or you're confused, and of course ask questions. So the warm-up, I'm gonna go actually to the Amplify slide so that I can see this for you guys. So this is what you should be looking at on your warm-up. And it's referring to the hole in the ozone layer that you read the other day or yesterday. And it says, answer the following questions about the articles. Again, you can always review the article if you need more help. It's right up here. If you click there, it'll bring you right to the article. Based on what you read, what is true about gases in the atmosphere? All gases in the atmosphere affect the energy the same way. Different gases in the atmosphere affect energy differently. No gases in the atmosphere affect energy at all. Ozone is the only gas in the atmosphere. Well, we know that this is not true because we've talked about other things in the atmosphere. And again, this one, we did a whole lesson the other day about how gases are affected. Now, these two answers, all gases affect the energy the same way, we found that not to be true in our simulation and also in the article about ozones, because some let different kinds of light and then also different kinds of energy absorbed or released based on the gases. And it says, based on what you read, what is true about the ozone hole? The ozone hole caused warmer global temperatures. The ozone hole caused cooler average temperatures. And then the ozone did not affect global average temperatures. It's actually that it didn't actually affect the average temperature. What it did do is allow more UVB light onto Earth, which is a non-visible light. So we have light that is visible or invisible. And the light that we call UV or ultraviolet lights are what we use for sunblock. If you put sunblock on, it's blocking those kinds of energy and light from the sun. So it actually didn't affect temperature. It affected the fact that it allowed more ultraviolet light, causing different kinds of skin cancer and things like this for humans and other animals on the planet. So we're going to keep going, and we're going to go to the next activity. So I'm going to go back to my slides because I worked so hard on making them so nice for you guys. All right, so we have the Chapter 1 question, and it says, why is the ice on Earth's surface melting? Now, going to our claims, we have increasing carbon, increasing methane, or decreasing sulfur dioxide. Either one of these answers so far have not been proven or disproven. We had the ozone layer on here for a little while. However, our article showed us that the ozone layer was not really affecting the ice so much on Earth, but affecting the living things on Earth. So we're going to look closely at these 3 claims and see if we can eliminate or choose one of the claims available. So, evidence. We talked about evidence. Again, I'm going to go back to your slides. And when we talk about picking evidence, We want to pick evidence that shows the longest period of time, because with climate change, we're studying a long period of time. So we would like to use the data from as far back as we possibly can to make sure that we're getting the most valuable information. We're showing what are the trends for a long period of time, because again, we're looking at climate change, and climate change is the study of the change of weather over a long period of time. That should be very simple. All right, now let's get into analyzing gas temperatures. Now, we talked about trends and fluctuations. So here we have the graph without any circles and stuff like that. And we can see that the average temperature, the trend, is that it's going up, right? If it was going down, it would look more like this. If it was staying flat, it would look more like this, going straight across. But here we can see that it's increasing. So it is getting warmer. Now, so you're going to look over some of the data here, and I want you to analyze what's going on. Here we're looking at the carbon dioxide trend. Again, the reason why I'm doing this is because right now we are looking at the 3 different claims: carbon dioxide, methane, and sulfur dioxide. So again, going back to the slides, there we go. Going back to amplify, you have the idea of carbon dioxide. So compare the trends for carbon dioxide and temperature. Here we have the temperature, and it's increasing. And I'm going to zoom in a little bit to show you guys this. It's increasing right around, there's a big little jump here, but let's look at this map. It kind of makes a U, or not a U, a curve. This also seems to make a curve. So if we compare them, do these graphs show the same trend? Yes. I'm going to press save and continue. Methane. Let's also compare the methane to the graphs, to the temperature. Here again, the same graph with temperature, and we have almost identical increases. Right around here, you see the bend and it goes up. Same thing with the carbon dioxide. So here we also see that the trend and the methane are related. Now, let's go to sulfur dioxide, our last claim. Now, sulfur dioxide from 1900, which is right before the 1880s, right after, it's kind of going up, down, up, down. Right here, you can see the trend is actually going down. Here, it's pretty stable. It goes up, and then it goes down. The average temperatures are simply going up. So these, even though sulfur has the opposite effect as carbon dioxide and methane, nonetheless, they don't match. If they were related, we would see sulfur starting up here and going down to show that the less sulfur would increase the temperature, but we're not seeing that. We don't actually see the decrease until later on, but it doesn't follow the trend very closely. However, there is still 1980s going down, but the trend is a little less obvious. So this might actually be related for different reasons, which we might look at later. Hint, hint, we will. But right now, the trend is that it's not related. The sulfur dioxide and the average temperatures are not following the same trend. So let's save and continue. Now, it says, which of the following claims do you think might be supported by the graph evidence? You might choose more than one. I'm not sure if it lets you. Okay, it does. So we know that the decreasing in sulfur was the only one that didn't actually follow the trend. So it would make the most sense that if you choose A and B, because both of those follow the trend of temperature almost exactly. So you might want to explain your thinking and explain what you're doing and why you chose those two. Again, use information from the graphs to support your answer. And I'm just going to write answer so that I can move on. Again, save and continue. We have two vocabulary words here. We have carbon dioxide, which is a molecule made of carbon and oxygen. And then methane is actually also made of carbon, but with hydrogen. Now, all three of these are atoms you've seen before. They're molecules you've seen before, with hydrogen and oxygen making water, and then carbon dioxide as these two together, and then carbon and hydrogen, which is the only one that should be new, methane. Now, we've talked about these three in prior units. So we are going to keep with these three molecules, and we're going to see how they play a role in the bio realm of playing into climate change. And again, hand in. So it says, congratulations, your work has been completed. Great. Now go to the next activity. You can either click here or here. This is where it's going to take a little bit of more time, and I applaud my friends who are really good at making little anime things or any type of computer graphics, because it's going to help you. What I want you to do is make a model to show your ideas of why the Earth's surface is decreasing. The ice on the Earth's surface is decreasing, and temperatures are increasing. To get to the model, you need to click on ice and temperature. And inside the model, you're going to do the before and after. So you can show methane, nitrogen. We can have low temperatures. I don't know why it won't let me drag. So again, this is before the change, and this is after. During here, we're going to have a low energy absorbed, and possibly after, because there's more sunlight, a high energy absorbed. Amount of surface ice, it doesn't let you change it. Just let you change this one. We might put a medium or even a large amount. Again, you can redo and add a large amount. Reset. Again. Doesn't let you change the temperatures because they're saying that the temperatures are we already know that it's a medium and high temperature. But what it does let you show is that, again, this is locked as well. Low ice, a lot of ice. What molecule was it that caused it? That's up to you to choose. We didn't talk about nitrogen today because nitrogen showed us that it didn't really have an effect at all when we did the simulator. So we only really talked about methane, carbon dioxide, and sulfur dioxide. And today we've knocked out sulfur dioxide, and we're really only focusing on carbon dioxide and methane, which only differ that this has hydrogen and this has oxygen. When you're done making your model, showing me the difference, which would probably look like a little bit of low and then a high amount, and that's pretty much all you really have to do. You have to choose either methane or carbon dioxide, low amount to high amount. You need to click hand in. This is the one you need to work on. I wouldn't even play with that, okay? Now, this is going to bring you to a different model that you would have to do. Okay? So only use the one that it sends you to. Now, when you click hand in, the picture actually uploads for me. So you don't even have to do anything over here but press hand in when you're in the modeling tool. So again, you make the diagram, click hand in, and that's all you have to do to get the picture to show up. Now, you explain your model of what's happening. You might say something like there was a low amount of carbon dioxide and then there was an increase, so the temperature increased because more sunlight was being absorbed and the ice started to melt because the temperature got hotter. Now, if you chose, you can only really choose one atom at a time or one molecule at a time. The second page allows you to do the second model. So if you did carbon dioxide here, you might want to do methane for the second one. But again, make sure you click here, because if you look at the difference, this is just ice and temperature. This is ice and temperature too. So I would get here, and now I did methane first, so I might do carbon dioxide. Again, click hand in. Go back to the curriculum and explain my answer. What did I give? What added? What changed? Why did the change cause this? And what evidence do you have from the graphs? Again, press update. And click next activity. Now for homework, you're going to go to the regular simulator and try to make Earth as cold as possible. Change things on Earth to make it as cold as possible. And I want you to explain what you did. And again, when you do this, I'm trying to find the way to take a picture of this. You would have to take a picture using screenshot. So I'm not going to require you to do this, but I want you to answer just the first two questions on how you made the Earth cold. So again, you're going to have 2 days to complete this. I would really appreciate if you make sure that for your modeling tool you use a CER, what your claim is, that the more carbon dioxide, your evidence is from your graphs, your reasoning, and then explain what your model shows. And again, you have 2 days to complete this.